Okay, so I feel like this video is going to be less than 3 minutes if I don't do anything or add any filler, so it's April 20th today, so so for problem 24.16, we're looking for the electric fluxes between two cylinders with different electric fields. So for part A, we're looking for the one cylinder A, and I'll show you why the answer is zero. So anyways, here's cylinder A. He is going parallel to the cylinder. So yeah, and we have to put the answer in terms of E, R, and pi. So yeah. So as you can see, this is the general equation for electric flux. So E times electric field times area times cosine of theta. In this case, it's going to be 180 degrees. Your calculator better be in degrees, or your knees go bye bye. But anyways, yeah. So assuming that we're getting the difference between the two, we're gonna get the sum of the two electric fields from the left side, the left side of the electric field and the right side of the electric field. We have to get the EA times cosine of the other side, so it's 180 degrees, and cosine of zero, the cosine of zero is 1, while the cosine of 180 degrees is -1. So you're basically subtracting EA from EA. You're basically taking all the money away from EA, basically. So EA minus EA is 0, and that also takes away the DLCs that are exorbitantly expensive as well. So therefore your answer for part A should be 0. So for part B, we are looking for that electric flux through cylinder B shown in figure 2. So now this time there are two different electric fields is going the opposite direction. So they're both going the opposite direction. So one of them has to be negative. So yeah, and we'll assume that at pi radians or 180 degrees, that the electric field going left is negative. So now you have to that's EA cosine 0 plus the negative electric field times area times the cosine of 180. Remember that the cosine of 180 is 1, but a negative times a negative is a positive. So yeah. So now you're basically doubling the EA, so you're also doubling the cost of the DLCs that are already exorbitant enough. So yeah, and now you plug in A, and well, it's only parallel. But the electric fields are only parallel to no, excuse me, perpendicular to the circles of the cylinder. So we don't really have to we don't have to like talk about the surface area of the can's label, just the lid and the bottom. So yeah. So the area of a circle is pi r squared. So your answer should be two times the electric field, pi r, uh but actually pi r squared. So yeah, that should be your answer for part B. Except in the Mastering Physics, the r is capital. So yeah. Anyways, that's your answer for part B. I know I should have put the phi. But anyways, if you like this video, please drop a dislike, and see y'all in the next video. And happy April 20th.